Yeah, hi everyone. Welcome to my Max Academy. In this session, we will do the division algorithm for polynomials. So we will continue the polynomials chapter. The section that we will do now is division algorithm for polynomials. Right? So, I'll write. So it is division algorithm for polynomials. This is an algorithm for polynomials. Fine. So before we get on to the division algorithm for polynomials, we will do some division of polynomials. So let's see example 6. Example 6 is in the textbook, page number 33. In the page number 33, we'll do the example 6, wherein we are going to divide two polynomials. Now divide, the question is divide 2x square plus 3x plus 1 by, we will divide this by x plus 2. We will divide this by x plus 2. So obviously this is the dividend and this is the divisor, right? So how do we do you might have done this in your earlier classes, how to do the division of two polynomials. So x plus 2, then this is 2x square plus 3x plus 1. We are going to divide this polynomial by this polynomial and we are going to find the quotient and remainder. So how do we divide two polynomials? So this is 2x square. So how to do step 1 is first we will take the first term here and first term here. Right? So what is the first term here, which is 2x square divided by first term here is x. Right? So when you are writing the polynomials here, you have to write in such a way that you are writing them in the order of decreasing powers of x. So you should have x square, then x, then the constant. Suppose if you have a cubic polynomial here. So if you have something cube like 2x cube, then x square term, then x term, then the number term. So similarly here also you will write in the powers of decreasing powers of x. So first you will write the x with the highest power, then the next x with the next highest power, so on and so forth. So after you write that, we will take the first term of this and first term of divide this first term by this first term. So 2x square by x. 2x square by x is what? 2x. Right? So we'll get 2x here. Now after you do that, then we need to take this 2x and multiply with this the entire x plus 2. So 2x into x plus 2. So what is 2x into x plus 2? When you multiply 2x into x is 2x square plus 2x into 2 is 4x. Right? So first you take this term, divide by this, whatever you get here, you have to put that as the quotient, first term of the quotient. Then take this and multiply with this entire thing. Then you will get here 2x square plus 4x. So whatever you get here, you put that here. Now we have to subtract them. So you will change the sign. So this is plus, it becomes minus. So this is plus, it becomes minus. Now this is 2x square, then this is minus 2x square, because once you change the sign, you have to always see the change the sign. So we are basically subtracting. So whenever you subtract, you will change the sign. So if it is plus, you will put minus. If it is minus, you will put plus. Here both are plus, so I am putting minus. So this is plus 2x square minus 2x square. Cancel, right? Then we have plus 3x, this is minus 4. What is plus 3 minus 4 is minus x. Right? Plus 3 minus 4 is minus 1, so minus 1x, which is minus x. Then we will bring in this 1 here, plus 1. Right? Then again we will take the first term of this with the first term of this. So what is the first term here? That is minus x by first term of this is x. We will take the first term of this and first term of this. Right? First term of this is minus x divided by x. Now what is minus x by x? It is minus 1. So you will put that minus 1 here. then we will take this minus 1 and multiply with x plus 2. So minus 1 into x plus 2. With this minus 1, you have to multiply this x plus 2. So what is it? Minus 1 into x is minus x. Minus 1 into plus 2 is minus 2. Then we will put here minus x minus 2. So this one minus x minus 2. Then we will change the sign. So this is minus. So we should put plus because we are subtracting. And this is minus. So we will put plus. So minus x. This is plus x. Don't think this is the bracket one that I am writing is the change the sign. So always you have to see the change sign. So change sign. So the new sign is plus. This is plus x. This is minus x. They will get cancelled. This is plus 1. This is plus 2. Plus 1 plus 2 is 3 plus 3. So we have done the division of polynomial. So this is the quotient and this is the remainder. So the quotient is 2x minus 1. The remainder is 3. Fine. And this we call it as the divisor. This polynomial is the divisor and this polynomial is the dividend. This polynomial is the dividend. So then what the division algorithm for polynomial says is, it says that your dividend equal to divisor into quotient plus remainder. So this is the general division algorithm, but for polynomials we will put the, now we are going to write the division algorithm for, this is general division algorithm. Now division algorithm for polynomial is division algorithm for polynomials. Division algorithm for polynomials says that p of x equal to g of x into q of x plus r of x, and either your r of x is equal to 0 or your degree of g of x, degree of r of x is less than degree of g of x. Right? So which means it will satisfy this condition. So obviously this is your p of x, this polynomial is your p of x, and this is your, the divisor is called as g of x. Right? The dividend I can put here. The dividend is called as p of x, and your divisor is g of x. This is your q of x, quotient, and this is your r of x. Fine. So then this is always true. Your p of x will be equal to, this polynomial will be equal to g of x into q of x. G of x is this into q of x is this plus the remainder polynomial. To do that you will get back your p of x, and your either the remainder will be 0, right? So it should satisfy both the conditions. The division algorithm will satisfy both the conditions. So this condition where your p of x will be equal to g of x into q of x plus r of x, and either your remainder should be equal to 0 or the degree of the remainder should be less than the degree of the divisor. Degree of the remainder, r of x is the remainder polynomial, g of x is the divisor polynomial, the one which divides, right? So whenever you get your degree of r of x is less than degree of g of x, we should stop the division. Or sometimes your r of x may become 0. If r of x is 0, then we can't talk about the degree because degree is not defined for a 0 polynomial, which you would have studied in earlier class. So now we will verify the division algorithm for this. Now we have done the division, right? For this particular case, let's try to verify the division algorithm. So if they ask you to verify the division algorithm, we need to verify these 2 points. Now for this problem we have done the division. We are going to now verify the division algorithm for polynomials. So what we will do, we will try to find this g of x, verifying division algorithm. Division algorithm for polynomials. Right, verifying division algorithm for polynomials for polynomials. So which means for this problem let's verify. Now let's try to do this. If I try to do this, I should get back my p of x, which is this polynomial. Right, so let's do g of x. So g of x into q of x plus r of x. So we are going to find the value of this. What is the value of this? What is the value of this? This should be equal to p of x. It should be equal to p of x. So let's what is g of x? G of x is x plus 2 into q of x. Q of x is 2x minus 1 plus r of x. What is r of x? 3. If you do this, if you multiply your g of x, which is the divisor, with q of x, which is the quotient, and then if you add the remainder, you will get the dividend. You get the dividend polynomial. So when you multiply this, what do we get? X into 2x is 2x square. You do this into this, right? Then x into minus 1 is minus x. Right? Then 2 into 2x is 4x, and 2 into minus 1 is minus 2 plus 3. In case if it is confusing, I can write one more step. We can write this as x into, with this x I have to multiply this 4, 2x minus 1 plus 2 into 2x minus 1 plus 3. So x into this whole thing, and then 2 into this whole thing, 2 into 2x minus 1 plus 3. Right? Then again we can multiply x into 2x is 2x square, x into minus 1 is minus x, 2 into 2x is 4x, 2 into minus 1 is minus 2 plus 3. That is equal to 2x square. Now minus x plus 4x is plus 3x. Then minus 2 plus 3 is plus 1. So what we have got back now? We have got back the dividend, which is this. We have got this back, and that is called as p of x. So your g of x into q of x plus r of x is equal to p of x. So which means this first condition is satisfied. Now second condition is you have to check whether the remainder is 0. Is the remainder 0? No. So remainder is not 0. So which means you have to check this condition. You have to check any one of this condition here. So this is one condition. This has to be checked. And second condition has two conditions. You have to check any one of them should be true. Now here is the remainder 0? No. Then we need to check this condition. We need to check this condition. Now to check this condition, what do? We will try to find, and write it here. We will try to find what is the degree of r of x. What is degree of r of x? What is degree of r of x? R of x is a constant polynomial which is only 3. So the degree is 0. Degree is 0. Then degree of g of x. Degree of g of x. Degree of g of x is what? Degree of g of x is, which means you have to find the degree of this. What is the degree of the polynomial? Degree of the polynomial is the highest power of the variable. Right? Degree of the polynomial is the highest power of the variable. So what is the highest power of the variable in the polynomial? It is x power 1. Here it is x power 0. So highest degree is 1. So degree of g of x highest power is 1. So degree is 1. Now, so therefore degree of r of x is 0. Degree of g of x is 1. So degree of r of x is less than degree of g of x. So that condition is satisfied. So we have satisfied this condition. So this is definitely we should satisfy, which you have satisfied. We have checked here. Then either this should be checked or this should be checked. One of them should be true. Here this has to be true for sure. This condition we have to check. In the second condition we have an option. Either this should be true or this should be true. Clear? So now we have verified the division algorithm for this particular problem, wherein we have proved, we have showed that the value of this entire thing gives me p of x, which is this. So we can write here g of x into q of x plus r of x gives me p of x, and degree of r of x is less than degree, because this is 0, here degree of g of x is 1. So this condition is also satisfied. Clear? So you may be wondering how degree of r of x is 0. See, r of x is what? R of x is 3. So which means r of x is 3 can be written as 3 into x power 0. Now what is the power of the variable here? 0. And this is the only term. So this is the highest power. Highest power is called as degree. So the degree is 0. So here it is x power is 1 and 2 is 2 into x power 0. So here x power is 0, here x power is 1. Among 1 and 0 which is greatest? 1. So degree is 1 for g of x, and therefore and 0 is less than 1. 0 is, so always your degree of r of x should be less than degree of g of x. The degree of the remainder polynomial should be always less than the degree of the divisor polynomial, or your degree or your remainder may become 0. If the remainder is 0, we'll stop. If the remainder is 0 means you will not check this condition. If the remainder is not 0, then you have to check this condition. Fine? Okay, so this is how we divide two polynomials, and then we divide one polynomial by other polynomial. Generally the polynomial that we are going to the dividend, this is called as p of x, and this is called as g of x. And when you get the quotient, then it's called as q of x, and the remainder is called as r of x. Fine? So we will do one more problem. Let's do example. See, example 7 you can try as homework. I will do example 8. Okay, let's do example 8. Let me erase this. So example 7 you can do as try as homework. I will do example 8. Now, example 7 is similar to the previous one. Example 6. So example 8 is also the same thing, but it is little, it looks a little bigger than example. It looks a little bigger than example 6. So I am doing example 8 now. I will just change the marker. Just give me a minute. Taking a new marker. So okay. So what we have is now we will do example 8 in page number 34 in your textbook. Now divide. The question is divide 3x square minus x cube minus 3x plus 5. Divide this by 1 minus x, x minus 1. X minus 1 minus x square. Divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square. So obviously this is your p of x, this is your p of x, and this is your g of x. This is your dividend, this is your divisor, right? So we will write this. So I told you, when you are writing this here, so this will obviously come inside. So when you write this, you have to write first the highest power of x, then the next highest, then the next highest. So it should come in the decreasing powers of x. So minus x cube. So you don't write this x cube, you have to write along with the minus, because the sign of x cube is minus. So minus x cube, the term is minus x cube, then plus 3x square minus 3x plus 5. So you have to first arrange it like, first the cube should come, then square, then x, then the constant. So 3, 2, 1, 0. The power should keep decreasing. That is all. It's not given in the, don't write as it is, like 3x square minus x cube. Don't write as it is like this. Then your entire problem will become wrong. That always, for any division of polynomials, should always write the highest power first, then the next highest power of the variable, so on and so forth. The same way you have to do here also. So which is highest power x square? So you have to write as minus x square, because that is, you have to write along with the sign. So minus x square plus x, then minus 1. Fine? Suppose if any term is not there, suppose if there is no x square term here, the problem is like this: minus x cube minus 3x plus, then you have to put 0 x square. You should make sure that after x cube you have x square. If you don't have an x square term after x cube, you should write x square. If x square term is not there, suppose the question is like this, then you need to put 0 x square. So wherever any particular term is missing, you have to put 0 for that. Now here x square is there, so I am just going back to the original question, so which is 3x square. Now how do we divide? I told you, you have to take the first term of this by divide by first term of this. So what is this? So let's take here. So the first term of this is minus x cube by minus x square. That gives me x. Minus minus will get cancelled. Now that x you should put it here. So this is x. Now x into this whole thing. To multiply x with this whole thing, that is what? Minus x square plus x minus 1. Now when you multiply, what do you get? X into x square is minus x cube, x into x is x square, x into minus 1 is minus x. Now put that value. Whatever you got here, after multiplying this with this, you get this, that you should substitute here. Minus x cube plus x square minus x. Right, here the problem is just to divide. They are not asking you to verify the division. Oh, okay, sorry, they are saying verify the division algorithm also. Yes, so you have to divide this with this and verify. And verify division algorithm. So both. First we need to divide and then we have to verify the division algorithm. So now we got this, then change the sign, then change the sign. So minus will become plus, plus will become minus, minus will become plus. Now this is minus x cube, this is plus x cube, they will get cancelled. Now this is plus 3 minus 1 is plus 2x square, minus 3 plus 1 is minus 2x. Then we will bring down this sign. Right? Now just to check whether we will proceed or not, you need to check, always make sure that what is the degree of this. This is the remainder, as far as the remainder. But to proceed or we have to stop here, we have to check the remainder of r of x. What is the remainder of r of x? 2. What is the remainder of, sorry, what is the degree? What is the degree of the remainder? Degree is the highest power of the variable, which is the highest power, 2. Here what is the degree? The highest power, that is also 2. 2 and 2. So the degrees are equal. Degree of r of x is equal to degree of g of x. But we should get degree of r of x is less than, so till the degree of the remainder is less than the degree of the divisor, we should continue to divide, which means again once you bring down this sign, you have to take this, take the first term of this, which is 2x square, divide that 2x square by minus x square, you get minus 2, right? Put that minus 2 here. Then with the minus 2 you need to multiply with everything, minus x square plus x minus 1. Clear? So minus 2 into, now multiply, minus 2 into minus x square is 2x square, minus 2 into plus x is minus 2x, minus 2 into minus 1 is plus 2. So we will substitute that here. So we get 2x square minus 2x plus 2. Then change the sign. Minus will plus minus, minus will become plus, plus will become minus. Right? Now this 2x square, 2x square gone, cancel, this is plus 2x, this is minus 5, this is plus 2x. That is also gone. Now plus 5 minus 2 is 3. So here also we got the remainder as 3. Right? So we will write what is the quotient. Quotient is x minus 2 and the remainder is 3. Remainder is 3. Now we should take the division algorithm. Division algorithm is this. Either this should be satisfied, then one of these conditions. Right? So for that, what do we do? To verify the division algorithm, so we will say verification of division algorithm. So for that, what do we do? First we will try to find this one, g of x into q of x plus r of x. We have to find the value of this, and we should say that is equal to p of x. We should get this. So what is g of x? G of x is this. So this is your g of x, this is your p of x, this is your q of x, this is your r of x. Right? So now g of x is this, so which is minus x square plus x minus 1 into q of x. Q of x is x minus 2 plus r of x. R of x is 3. Now let's do a normal multiplication. So if we do multiply, what do we get? So we get minus x square into x minus 2. Minus x square into x minus 2, which means this into x minus 2. Then plus x into x minus 2. Plus x into this into again the whole thing, x minus 2. Then minus 1 into again this whole thing, x minus 2 plus 3. That is equal to minus x square into x is minus x cube. This is plus 2x square minus x square into minus 2 is plus 2x square. And x into x is x square. X into minus 2 is minus 2x. Minus x is plus 2 plus 3. Now minus x cube, then x square times 3, x 3 2x square plus x square is 3x square. Then minus 2x minus x is minus 3x. These two will give you minus 3x. These two will give you plus 2 plus 3 is 5. You can add only the like terms, right? X square terms you can add. X and x you can add. You cannot add x square and 2x. These two are unlike terms. Unlike terms you cannot add. You have to add only the like terms. Here only x cube is what I have put. Here x square is there, here also x square. 2x square is x square. 2x square plus x square is 3x square. Minus 2x minus x is minus 3x. Then 2 plus 3 is 5. Now what we got back? We got back this. So which is equal to P of x. So we have verified one condition for division algorithm, g of x into q of x plus r of x is equal to p of x. Now second is we have to check whether the next condition is what we have to check. We have to check whether the remainder is 0. Is the remainder 0? R of x is 0? No. When the remainder is not 0, then we need to check whether degree of the remainder is less than degree of r of x. Now what is the degree of continuation of this? Second part check is degree of r of x. What is degree of the remainder? It is what? 3. Right? R of x is 3. What is degree of r of x? Degree of r of x is the highest power of the variable. There is no variable here. It is only 3, which means variable power is 0. 3 can be written as 3 into x power 0. So variable's power is what? 0. And that is the only term. So highest power is 0. So the degree is 0. So degree of r of x is 0. Then what is degree of g of x? G of x is this polynomial. What is the degree? What is the highest power of the variable? 2. So degree is 2. So we have found degree of r of x is less than degree of g of x. So we have to check this condition and this condition. Suppose if the remainder is 0. Suppose if we get remainder as 0, not 3, some remainder is 0. Then we will not check this degree condition. You can just say remainder is 0. R of x is 0. If R of x is 0, you don't have to check this condition. You will just say R of x is, there is a difference. Degree of R of x is 0 is different from R of x is 0. R of x is 0 means the polynomial itself is 0. The degree of R of x means the highest power of the variable is 0. That is the meaning of degree. Right? So we have verified the division algorithm. So this is also satisfied. This is also satisfied. Right? Okay. So this is how we do addition of two polynomials, and you verify the relationship. Also, you verify the division algorithm, not the relationship. You verify the division algorithm for polynomials. Clear? So now I would say you can try in exercise 2.3 the first problem, where you need to divide and then find the quotient and remainder in each of the following cases. You have to divide the two polynomials. Fine. Probably what I will do is you give it a try in exercise 2.3. Do the first problem. It has 3 sub problems. You give it a try. But if not, next class I will do some problems, similar problems. I will give it as homework. Right? Once I do a particular type of problem, then I will give that as homework. You can try, and if you have any question, you can always contact me through this WhatsApp number. You can WhatsApp me and I will try to clarify your doubts. So we will stop here. In the next session I will teach you the remaining part of polynomials. So we'll stop here and we'll meet in the next video. Thanks for watching.